Alright, so I think this is recording. We're looking at review problems for our Skill 4 packet, which is polynomial functions and rational functions. And here we're given a rational function, and they've asked us to find a whole list of things. To find the x-intercept, we let y equal 0. So we need to begin with factoring both the numerator and denominator. Two values that multiply together to give me, well, my factors of 20, 1 and 20, 2 and 10, 4 and 5. Well, 4 and 5 will probably work. If I make 4 negative, that'll be a negative 8. And here, because 2 times negative 4 and then the plus 5, I'll get a minus 3. In the denominator, I see that both have a common factor of x, and I have 2x plus 5. Alright, so I see that I have a common factor in the numerator and denominator that cancel. So now that I have this fraction in lowest terms, I can recognize that if this fraction does equal 0, it's because the numerator is 0. Okay? Not the denominator. It can never be 0. Well, if I set this numerator equal to 0, it's extremely easy to solve. X equals 4. So there's my x-intercept. Just a single x-intercept at x equals 4. Well, what about the y-intercepts? Y-intercept is easier. If there is one, there'll be exactly one. There could have been multiple x-intercepts. To find the y-intercept, you let x equal 0. We plug 0 into the function. In the numerator, the first two terms would be 0, and that constant term, negative 20. But in the denominator, both of these are 0. 0 plus 0, 0. So it's undefined. There is no y-intercept. Division by 0 is undefined. Alright, so now it's asking us to continue to analyze this graph, or this function, to determine the end behavior. So let me erase this. To determine the end behavior, I'm going to compare the degree of the numerator against the degree of the denominator. Whenever you compare two values, you only have one of three possible results. Here, if the degrees are equal to each other, the outcome, the end behavior is a horizontal asymptote. And it's the line, well, we take a ratio of the leading coefficients when the degrees are equal to each other. So this leading coefficient in the numerator is 2, and in the denominator it's also 2, and 2 divided by 2 is 1. Now, some people might describe this end behavior by saying that as x is going to negative infinity and as x is going to positive infinity, this graph, well, it's approaching its horizontal asymptote. Graphs always approach the asymptotes. So either one is acceptable for describing that end behavior. Alright, now it wants me to determine the location of any vertical asymptotes or holes. And of course, I erased my factored form of this. So let's factor it again real quick. 2x plus 5 was a factor, I believe. And then x minus 4. Because a positive 2 times a negative 4 was negative 8. Negative 8 plus 5, negative 3. Yes. Alright, so we have a vertical asymptote. It's the line x equals 0. Well, that's more commonly called the y-axis. Now, if that's the only vertical asymptote that it had, was just one vertical asymptote. When these factors canceled, it created a hole in the graph. we want to give the location of that hole. The x-coordinate, well, we take the factor that canceled, 2x plus 5, and set it equal to 0, and solve. Subtract 5 from both sides and divide by 2, and we have that negative 5 halves is the x-coordinate for this hole. To determine the y-coordinate, I can't plug negative 5 halves into the original expression. It would give me 0 divided by 0. I do want to plug it into the expression only in reduced form. So this fraction, this ratio after it has been reduced, let's come down here. Instead of x minus 4, we've got negative 5 halves minus 4. I'm going to rewrite 4 as 8 divided by 2, so it has a common denominator. In the denominator here, I have a negative 5 halves. Let's see what this simplifies to. Well, in the numerator, the negative 5 minus 8, hey, that's a negative 13. That over 2, and that 2 is going to cancel the 2 in the denominator that's in the numerator is going to cancel with the 2 that's in the denominator of the denominator. And a negative divided by a negative is positive. So I have 13 over 5. So I hope I haven't made any silly arithmetic errors. And I believe we're done. Let's look and see if the next problem has the same directions or, well, I don't have the next problem on here. Oh, there it is. All right. So yes, it does have the same directions, so we may as well put it on the same video. If we're finding the x-intercepts, we want to write this in factored form. The greatest common factor in the numerator is x, and the denominator is 3. The numerator, that trinomial, factors to x minus 10. No, it does not. Oh, 4 and 5. Huh. X minus 4, x minus 5. Negative times negative gives me positive, but if I add them up, I get a negative 9. And here, with a negative, the larger in magnitude is going to be negative, so the minus 4 plus 2. And we see that we do have a factor that cancels. Our numerator then is x times x minus 5, and our denominator 3 times the quantity x plus 2. So if they want me to find x-intercepts, I let y equal 0, which is the output of this function, and I set that numerator of the reduced expression equal to 0, and solve this equation. That's not a good looking 5. Solve this equation. So x equals 0, x equals 5 are the x-intercepts for this function. To find the y-intercept, we plug in 0. In the numerator, since we have all these x's, this just reduces to 0. And in the denominator, we've got a negative 24, that constant. So this is 0. Well, that was to be expected. If x equals 0, then we know that, and here, well, I don't know, I expected it to go through the origin here. Maybe it could have had a different y-intercept. Anyway, with x equals 0 being an x-intercept and the y-intercept being 0, this graph definitely passes through the origin. Alright, so that's the x-intercept, the y-intercept. It's now asking me what? To determine the end behavior. So my degree of my numerator is 3. The degree of my denominator is 2. I refer to this as top-heavy. The end behavior, there is no horizontal asymptote. I'm going to have to come in and determine, as you move far away from the origin, to the left or to the right, or as the output of the function, the y-coordinates, getting closer to something, or in this case, is it going to positive or negative infinity? Let's plug in extreme values. When x is very far to the left, when it's negative, the x cubed term dominates. These lower degree terms do not make a dent in affecting this number. If I plug in numbers that are extremely small, very far away from the origin to the left, very negative, I'm going to have a negative number as the base raised to an odd power. So that numerator is going to be a negative number. In the denominator, again, these lower terms really don't come into play here if you're far away from the origin. I have a positive number, and the x squared, well, I have some negative base raised to an even power. So when a negative value is raised to an odd power, that's going to be negative. When a negative value is raised to an even power, it's positive, and a positive times positive is positive. And this ratio is negative. So as x is approaching negative infinity, I conclude that y is also approaching negative infinity. Now let's plug in extreme values in the positive sense and see what we get here. In the numerator, we've got some positive value being raised to the third power. In the denominator, we've got some positive value squared times this positive 3. Well, this is a positive number divided by a positive number. That ratio is positive. So as x is approaching positive infinity, so is y. It's also approaching positive infinity. So here's my answer for the end behavior for this graph, for this function. Oh, it wants the any holes in the graph, any vertical asymptotes. So at some point do I still have it? I probably erased it, yeah. I factored this, and should have saved my work, huh? So in the numerator, x minus 5 and x minus 4. In the denominator, x plus 2, x minus 4. So, if I'm trying to determine, let's see, I determined the holes are the vertical asymptotes. For holes, I look and see that I did have a factor that canceled. So I want the x-coordinate and the y-coordinate of the hole. The x-coordinate's easy. Set the expression that canceled equal to 0 and solve for x. X minus 4 equals 0. Add 4 to both sides, and x is 4. To determine the y-coordinate for this hole, you plug x equals 4 into the function, but not the original function, into the reduced form after we've canceled out this x minus 4. Now, if we plug it in now, what do we get? We've got 4 in the numerator, and 4 minus 5 is a negative 1. We get a 4 in the denominator, or we plug in a 4 in the denominator, and 4 plus 2 is 6. So I have, well, I'm getting tired. 3 times 6, 18. Hey, those are both even numbers. So 4 over 18 reduces to 2 over 9, right? Yeah. All right. Now, for vertical asymptotes, it's what didn't cancel. And the 3 isn't going to make this denominator ever equal to 0. So x plus 2, we do have a vertical asymptote. It's the line x equals -2. So there we have it with number 24. So I hope that helps.